Okay, so the law of sines is wonderful. It allows us to solve a lot of triangles, but not every triangle. Okay? There are two situations that the law of sines does not work for. It does not work when we are given side, angle, side, and it does not work when we are given side, side, side. Okay? But we can solve those triangles, so we need another rule. That's where the law of cosines comes in. Okay? So we previously learned that any time that we have two angles and a side, we can use the law of sines. Okay? Again, the law of sines says that for any triangle, ABC, not very pointy, but that's okay, ABC, where A, B, and C are the opposite sides, the law of sines says that the sine of A over side length A is equal to the sine of angle B over side length B is equal to the sine of C divided by C. That's our law of sines, yes? Okay, we can do that anytime we're given two angles and a side length. Now, if we're given two side lengths as well, that works as well. That's the ambiguous case. Okay, it works for that as well. So that works for law of sines. However, if we were given side, angle, side, or side, 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 we need a new rule. Okay? That's going to be called the law of cosines. And one version is way easier than the other to solve. One is way easier than the other to solve. Okay, so the law of cosines states that if we square any side of a triangle, that square is always equal to the sum of the squares of the other two sides minus twice the product of those sides times the cosine of the opposite angle. And that's a lot of words. So look at the format there. Same triangle, ABC over there on the right. We're looking at C squared is always A squared plus B squared, that's the other two side lengths, minus 2 times A times B times the cosine of angle C. Notice little c and big C are the angle and side pair we'd be looking for. Okay? Same thing applies to all three sides. So this is the second form of the exact same rule. B squared is equal to A squared plus C squared minus 2AC cosine of angle B. Again, notice angle B has little b by itself on the other side of the equation. Whatever angle is here, that side length is by itself. So what would the third version of the law of cosines be? Okay, A squared equals B squared plus C squared minus 2 times BC times the cosine of A. Okay, the law of cosines could come in any of those forms. It depends on what we're trying to find. Okay? Notice that the isolated side is always paired with the angle in the formula. This is true for every triangle, no matter what shape, no matter what size. This is true for every triangle, which means we could use it technically in any problem. But it does require a little bit more work than some of our other rules, so we shouldn't use it unless we have to, which is side, angle, side, and side, side, side situations. Okay? That's what we use in side, 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 angle, side situations. Great question. Yes, this does look similar to the Pythagorean theorem. That is because the Pythagorean theorem is a special case of this law. You're used to seeing a squared plus b squared equals c squared, so if we look at this first form, side C would be the hypotenuse, and angle C would be the 90-degree angle. Well, we just got done doing a unit circle. On the unit circle, the cosine of 90 degrees is 0. So this entire term would drop out, leaving a squared plus b squared equals c squared, which is the Pythagorean theorem. So the Pythagorean theorem is a special case of the law of cosines. So there are two problem types where we're going to use the law of cosines. So let's discuss each of them and see some examples. The first type is when we need to solve for the third side length, which would be when we are given side, angle, side information. We will have to be finding the third side length. Okay? After we solve for that side length, our second step, we will have to use the law of sines to find an angle. And we always need to remember that we need to take the square root as we work through this portion of the problem. So let's take a look at an example of a side angle side problem. Okay, over there we've got two sides and the angle in between them. Yes? So this is not ambiguous case law of sines because we don't have a pair of angle and side, right? The angles between the two sides, that tells us this is a law of cosines problem. Okay? In this case, we use the version of the law of cosines for the angle that we know. So since we know angle C, that's the angle that will be in our law of cosines. So we're going to use the version that has c squared equals a squared plus b squared minus 2ab cosine of angle C, because we know angle C. Now, this is the easy mode version of law of cosines. It's the side angle side problem, because what we are trying to solve for is by itself already, except it's squared, right? Little c is what we are trying to find. So we just plug in everything else. Little a is 21. Little b is 16. Yep, little b is across from angle B. Little a is across from angle A. Minus 2 times 21 times 16 times the cosine of angle C, which is 72 degrees. Okay, we're going to take that, and it's going to get plugged into our calculators. Second, to write that down and feed it into your calculator. Okay, we're going to feed that into our calculators. 21 squared plus 16 squared minus 2 times 21 times 16 times the cosine of 72 degrees. And we get 489.3405798 is what my calculator shows. Okay, that's what my calculator shows. Now you might think to yourself, gee, that number looks big, and the answer is, it is big because that's not c. That is c squared. We still need to take the square root of that number. So our final step here would be to take the square root of each side. So we take the square root of that number, and we get 22.12. Let's just go 22. Let's call it let's go 22.1. 22.1 is, we've been rounding everything to the nearest tenth on our homework, so let's stick with that. Whoa, that's not good. Where'd that come from? It's pressed up here and it popped right up. So 22.1 is going to be the third side length of our triangle. Okay, this is 22.1 units. Okay, little c is 22.1 units. Now we still need to find the measure of angle A and the measure of angle B to finish solving the triangle. Okay? So now that we've found angle C, side length C, now we have an angle pair, so we can now run the law of sines. So, once we know little c, then we turn around and we say, all right, now that we know little c, we can set up the law of sines to say the sine of angle C over little c equals the sine of, I'm going to do A because it's bigger than B, over little a. Okay, sine of C over little c equals sine of A over little a. Okay, we're going to run the law of sines, and this will allow us to find a second angle, in this case, angle A. So that would be the sine of 72 degrees over 22.1 equals the sine of angle A over 21. Now, if we look at those numbers and how close they are to each other, 22.1 and 21, angle A should be just slightly smaller than angle C. It should be high 60s, low 70s, my guess. Okay, because those side lengths are almost the same, the angle should be almost the same. Okay? So we cross multiply, which will give us, I'm just going to keep going this direction, 22.1 times the sine of angle A equals 21 times the sine of 72. We divide by 22.1 to get sine of A by itself. And then to get A, we would need to take the inverse sine. So A is the arc sine or inverse sine of 21 sine 72 over 22.1, and we feed our calculator. I'm going to round that to the nearest degree because that's what we've been doing on our homeworks all along here. And we feed that into our calculator, and I'm seeing 64.7. 65, you're right, I said nearest degree. So 64.6, which rounds up to 67 degrees. 65, good Lord. 65 degrees, good catch. 65 degrees. 64.7 rounds up to 65 degrees. My brain is in great shape today, folks. Yeah, 64.6 means we round up. Okay, 65 degrees. Now, how do we find the third angle? Yep, 180 minus the other two. So our third and final piece, angle B, is 180 minus 72 minus 65. So 180 minus 72 minus 65. I no longer trust my brain, so put that into the calculator. That is 43 degrees, and that triangle is solved. All right, so we're doing the largest angle. We need to solve it like an equation. Got to use PEMDAS. And since we're finding angle A, we're going to use a squared equals b squared plus c squared minus 2bc cosine of angle A. So same idea. We plug in everything that we know. So we know little a is 13. We know little b is 8. We know little c is 11. And we do not know angle A. So when we finish plugging in, we have 13 squared equals 8 squared plus 11 squared minus 2 times 8 times 11 times the cosine of angle A. Now that PEMDAS talk from earlier, the reason that's there is here's the mistake you are going to make if you make one. Ready? You are going to put all of this into your calculator except for the cosine. And you can't do that because this multiplication right here between the 11 and the cosine, that has to happen before this subtraction can happen. Okay? So if you feed all of this to your calculator at once, your answer will be wrong. And that's the mistake people make because they're not listening to me right now. So that's the mistake they're going to make. I tell you, that's the first mistake every time. Okay? There are pieces of this that you can put into the calculator. You shouldn't need a calculator for 13 squared. That's 169. You can put 8 squared plus 11 squared in the calculator. Okay, you can do that. It's what, 185? Okay. And you can do 2 times 8 times 11 in your calculator. Okay? Which means negative 176, right? But from here, you have to solve for A, which means you have to solve for the cosine of A and then take the inverse cosine. So, this is basically a two-step equation to solve for cosine A. First, we subtract 185 from each side. Yes, that's a negative number. That's not a problem. Okay? So 169 minus 185 gives us negative 16 equals negative 176 cosine of angle A. Divide by negative 176. Which gives us the cosine of A, and that should be negative 176, is 16 over 176. There's no reason to turn it into a decimal. Which means A is the inverse cosine of 16 over 176. Feed your calculator. 84.7 would get rounded up to 85 degrees. Then from there, we have our angle pair, so we would switch over to law of sines to finish the problem. Okay? That is going to be where we have to stop class today. I'll finish this video during the passing period. So then from there, now that we have angle A, we would switch over and use the law of cosines. Oops, didn't mean to move that. We would switch over to the law of cosines to find one of the other angles. So we would say sine of A over little a equals the sine of, let's say, C over little c. So the sine of 85 over 13 equals the sine of angle C over 11. Of Cross multiply gives us 13 times the sine of angle C equals 11 times the sine of 85 degrees. We would then divide each side by 13 and take the inverse cosine. So we divide by 13, which would get sine C by itself, which means C is the inverse cosine of 11 sine 85 over 13. We feed that to our calculator. Second sine of 11 sine 85 over 13. Round it to the nearest degree would be 57 degrees for angle C. So we had angle A was 85 degrees. Angle C is 57 degrees. And that leaves angle B, which, since we know the other two angles, all we have to do is take those two angles and subtract them from 180 degrees. So angle B would be 180 minus 57 minus 85, or 38 degrees. 38 degrees. And that finishes solving that problem. I'll make an additional video with the remaining two examples from the notes, but that gives us a good background on what we need to be able to do